Alright, so this will be elimination video homework number 1. Again, just like the substitution problems, I've got 3 here. You don't need to go watch the substitution first, unless you just want to. You could do these first. But do them in order, 1, 2, and 3. So in green we have the first problem, and I'm going to ask you to provide the elimination product and tell me whether it's an E1 or an E2 mechanism. Okay, so we've got this alkyl bromide, sodium methoxide in methanol, CH3 or Me, either way. You'll see it both ways in the book and in my lectures and in chemistry in general. So again, we're basically mixing this alkyl bromide with these with this reagent in this solvent. So go away, hit pause, go away, tell me what the product and mechanism are. Okay, so you're back. You have to identify compound with leaving group. Bromide's going to be the leaving group. It's on a tertiary carbon. That didn't really tell you anything in differentiating an E1 and an E2. Remember, in substitution, if the leaving group is on a tertiary carbon, you cannot do SN2. It has to be SN1 if it's substitution. But you can do E2 reactions with a tertiary leaving group. In fact, they're really nice. They work very well. So you have to ask yourself, do we have a strong base or a good nucleophile? Methanol is just a solvent. Again, the oxygen-hydrogen bond is covalent. That oxygen has a neutral charge, so it's kind of a weak base, weak nucleophile. Sodium methoxide, on the other hand, the sodium is a plus. That means the methoxide is a minus. Methoxide is a strong base. It's also a good nucleophile. It's kind of small, but it's a strong base. So if you have a strong base, which is a good nucleophile, you're either going to do E2 or SN2. I'm asking you for elimination reactions, so that means it must be E2. So this tells you that it's E2. Alright, so what about an E2? Well, you've got 2 different protons, really. We can either take the CH2, one of the CH2 protons and make a double bond there. Take one of the methyl protons and make a double bond there. And so your choices are, go ahead and draw them out first. Those are the 2 alkenes that would be the choice. I'm going to see if they're actually on the screen. Yeah, it looks like they are. So we can eliminate there and make a double bond here, or we can eliminate this proton and make a double bond there. And now your choice is, what's the substitution? So this top one is mono-substituted, the bottom one is tri-substituted. There's no sort of stereoelectronic effects where you can only take one of the protons, and so in fact this would be the major product, and the mechanism would look like that. Methoxide would grab that proton, you make the double bond, you kick out bromide, all in a single step because it's an E2 reaction. And you can only do that if you have a strong base around. Alright, that's video elimination homework 1. The red one will be number 2.